This is the Binatone 024481 Professional. It's a peculiar calculator. This is not in a particular good shape. The on-off is gone here. The pi sign and the function sign that should be here, they are not visible as well. But apart from that, it's working. So it works with a 9 volts battery, very easy to replace. The calculator is light, it's as slim as it gets, it's thin, and it's quite small. It fits comfortably in your palm. For the sake of comparison, this is a modern calculator, the smallest that it would get in a practical sense. So this is not as bulky as most calculators of the 70s with LED display. The thing that's particularly interesting about this calculator is that it uses reverse Polish notation. So if you want to add 4 and 3, you would say 4 enter, 3 and then plus, which will give you 8. So there's no equal button on this calculator, which is unusual for calculators that it's a lower budget. It's not a HP, it's a calculator that it's trying to compete in this market. And reverse Polish notation never took off in other manufacturers, but this is an attempt to do that. So let's check that the calculator is working as it was supposed to. So first let's check all the digits. So it all works as it should, and the decimal separator works as well. So, and you see that the digits move to the right as you type them, which again is not standard practice, which means that if you want to check the decimal separator, you will need to do it one by one to see that they're all working. And the last one. Negative and positive is also working as it should. And the digits, the buttons are all working properly as well. That's it, the 8 and 9. They don't fit all in one go. So all working as it should. The plus we already checked. Let's see, minus for enter. 3 minus 1, correct. And 2 enter, 3 times 6. And 10 enter, 5 division 2. That's all as it was supposed to be. You have here the log functions, so 100, and then function log 2. See that it blinks while it's doing the calculation. So the programming was not done in such a way that to disable the display while the calculation is being done, which is quite curious in this model. And if we have 1 and we do the Euler number to the power of 1, we get the Euler number. And if we do the natural logarithm, we should come back to 1. As you see, there are some precision issues in this calculator. So it should be 1, but it doesn't show 1 as it was supposed to. So 25 square root here, 5 as it was supposed. And here a number to the power of other. So let's say 2 enter, 3 function to the power of, and 2 to the power of 3 is 8. Again, a very simple calculation, and it's already showing issues with the precision of the number. This one's for clear function, which the blue one, that it's unlikely that you're going to need that. Memory plus memory minus, as it was expected. So let's suppose I have 2.3, and I want to store it in the memory. So memory plus, and I can clear my entry, and if I need to retrieve that memory, I use the memory recover here, the 2.3, and then you can subtract numbers as well, or you can just place the number in the memory using the MS here. This D here is a very curious one. If you leave the calculator unattended for a while, it will change the display to save energy, and once it changes the display, it's going to show a number of dots, and After that, you can activate the calculator again using, there you go, using the D, and it will show the number that was being used before, which is handy, and but an unusual option as well. And there are no functions here. What else do we have? We have here the trigonometric functions, cosine before sine, which is a bit unusual. Let's go. This is, the default is on degrees, so 30, the sine should be 0.5, and 60, the cosine should be 0.5 as well, and 45, the tangent should be 1. Again, precision issues here on how this is calculated. And if we want to do the arc, you have here, so 1 arc tangent should be 45, and 0.5 arc sine should be 30, and 0.5 arc cosine should be 60. There you go. So these functions here are working as intended. If we want to change from degrees to radians, let's suppose that I have 180 degrees, and I want to see that in radians should be pi. And vice versa, if I have pi in radians and I want to see it in degrees, should be, again, precision issue here. You have pi as a number here, so if you press 1 to activate the function, and the second time it gives you pi. It's not readable, but that's the function. We have as well 1 over a number, so 2 function 1 over a number 0.5 as expected. And that covers all the functions. So we have here the exponential notation. Oh no, this is not the exponential. To exchange the number in the display with the number in the register. There's an explanation here in the manual. The manual is not bad. It's quite small, which is great because it fits in the same package. It's not in great shape, but again, not many of those around. In 2 colors, blue and black, and shows here different ways the display works. Error conditions, we can see them in a minute. And here is the stack for the 3 values that are stored in the calculation. So what this EX does here is to exchange between the numbers in different stacks. So you can even do some slightly more complicated calculations if you understand how the reverse Polish notation works. There are some calculation examples which are great, because if you're not familiar with this type of data entry, it becomes quite tricky. So you have quite a few of them. At the end, you have a few blank pages. Just curious to say the least. So planning was not a strong point here. And that's it. So, and you're back into the display mode. This Binatone Professional 024481, and it's a full glory, not a very common model around, and particularly unusual because it uses reverse Polish notation. And that's it.